Class 10, we have to take up now next topic, circles. Okay, so in circles, now last year also you've studied various theorems on circles. Now this time we have to focus on tangent to a circle. So I hope you all remember and have an idea about what a tangent is. See, in this figure, first one, this is a circle and this is a certain line which is outside the circle. Then if the line is cutting through the circle, if it is cutting the circle, then this line, such a line which cuts the circle, okay, A and B are 2 points at which it is cutting the circle. This is known as secant. The whole line is known as secant. And we remember last year we've done a number of theorems. AB, portion of this secant, जो ये portion circle का है, ये chord कहलाती थी, right? Okay. Now, if this line cutting, it becomes secant. If it is just touching the circle, like here, in the last figure, it is just touching the circle, means it is meeting at a single point. ये तो 2 points पे cut कर रही थी. It is meeting or touching it at a single point. Then this line is termed as a tangent. So we'll be doing various theorems about tangents out here. Tangent to a circle. Okay. So there are certain things that you'll read through this, children. Read through whatever is given here. Some important points have been highlighted here, like a tangent to a circle is a line that intersects the circle at only one point, as I've shown you just now in the figure. Okay, it just touches at a single point. Okay. Now, another important fact is there is only one tangent at a point of a circle. So there are various points obviously in a circle, but every point will have one fixed tangent. Okay, it's not that one child can draw a tangent like that, another one like this. Okay, all of you will have a unique tangent at one given point. If I choose a point here, same tangent will come as many times or as many children that draw it. Okay, so only one tangent at a point of a circle is there. Right. Next is the tangent to a circle is a special case of secant when two endpoints of its corresponding chord coincide. So that's just like you can understand ये secant है, जैसे इस secant को अगर आप shift करते जाओगे इधर तो इसका जो cut है, cut off portion वो छोटा होता जाएगा. Ultimately a position will come when this will be touching it only, or we can say the point will coincide with each other. Okay, so they are saying कि secant का एक special case है tangent. Alright, so nothing difficult or great about that. The next important thing is these definitions you've got to know. The common point of the tangent and the circle is called the point of contact. Okay, circle में हमने जहाँ पे भी tangent बनाई है, like this line out here is tangent to this particular circle. So ये point जो common point होता है where it intersects, this point lies on the circle as well as on this tangent line. So this point is called point of contact. Okay, and tangent said to touch the circle at that common point. Fine, that is nothing great. Now, what follows now is very important here, this theorem. Okay, the theorems on tangents we have to remember, use, as well as we have to see their proof. Okay, so the first theorem here is the tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, children, so as I read that theorem, first you need to understand the statement, then you've also got to see the proof. The proof is equally important. Now, when you start off with this work, which will be done in your geometry copies, then you'll make sure that first you jot down this theorem. सबसे पहले आप इसका पूरा proof लिखोगे, then you will move on to the exercise. Okay, so try to understand this, read through it. इसमें बहुत ज़्यादा, this is more kind of theoretical proof compared to mathematical proof. Okay, I'll explain you in my words. You read through what is given here and then try to express it likewise. Okay, so पहले तो proof theorem क्या रहा है, you need to understand. See, what are they saying is that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So in this figure that they have drawn here, there is this circle and this line xy is the tangent line. ये इसको एक पॉइंट पे टच कर रही है, तो ये P पॉइंट पे टच कर रही है, तो P हमारा पॉइंट ऑफ कॉन्टैक्ट कहलाता है. राइट, द पॉइंट वेयर or point common to the circle and the tangent line, or the point where the tangent touches the circle, is known as point of contact. Okay, so this line xy is tangent to a circle with center O and P is the point of contact. Then OP radius will be perpendicular to xy. This is what the theorem is saying. Okay, the radius through the point of contact. तो पॉइंट ऑफ कॉन्टैक्ट एंड सेंटर को आप ज्वाइन करोगे तो ये ओपी रेडियस हो गया थ्रू द पॉइंट ऑफ कॉन्टैक्ट. दिस ओपी वुड बी परपेंडिकुलर टू, मीन्स दिस एंगल आउट हियर विल बी अ राइट एंगल. ओके, ये 90 डिग्री का आपको प्रूफ करना है, ये 90 का आता है, राइट. सो व्हेन यू आर डूइंग द प्रूफ, बिकॉज एज आई हैव टोल्ड यू अर्लियर, थ्योरम्स में only the statement is there, you have to make the figure first and then you have to explain the figure कि figure में क्या क्या है, and then you have to proceed with the proof. तो same way यहाँ पे भी आप बताओगे ऐसी, consider a circle, ये इसने पूरा लिखा होगा, read through it and I'm just giving you a hint. Okay, so consider a circle with center O, let xy be the tangent at the point of contact P, then to prove that OP is perpendicular to xy. अब उसके लिए हम टेक्निक क्या यूज कर रहे हैं प्रूफ में? We will use the fact that the shortest distance on or is the perpendicular distance. किसी भी point से किसी भी line का जो shortest distance होता है वो perpendicular distance होता है. Keep that in mind, okay? The shortest distance is always perpendicular distance, right? So we'll have to show that this is the shortest distance, and how are we going to do that? Now for that we will say consider an arbitrary point on the tangent xy. P तो point of contact हो गया, तो other than point of contact you can take any other point. इसने यहाँ पे लिख दिया है Q, आप कहीं पे भी बना सकते हो, यहाँ यहाँ anywhere. Arbitrary, the word arbitrary means it is any and every point. Okay, so you will start by saying now consider an arbitrary point Q on the tangent. तो वो Q point कहीं भी हो सकता है, इसने यहाँ पे दिखा दिया है. Okay, so that is how we do it. Then we will join this Q to O now. Join OQ. Alright, now when you join OQ, now you can name this point as well out here. इसने करा नहीं है, for clarity if you want you can name this point out here also, say maybe M or any other name, R, कुछ भी name दे दो. Okay, now what you see here children is, now if you compare, we would say clearly OQ is greater than OP. Why? Because OP and OM are equal. Both of them are radii of the same circle. Radius तो एक circle का same होता है. So OP भी radius है, OM भी radius है. And ये OQ आपको दिख रहा है कि ये outside the circle जा रहा है, तो ये radius से बड़ा होगा. Okay, so we would say that OQ is greater than OP because OQ is OM plus MP. You getting that? Okay, so if this is, and Q was an arbitrary point, so what have we proved? That other than P, any point other than P is always going to be further than what P is from O. So OP is the shortest distance. Proof कर दिया हमने. Q कोई भी was any and every point. So we have shown that OQ length will always be more than OP, or the other way around, OP will be the shortest distance. And shortest distance is the perpendicular distance. Hence prove that OP is perpendicular to OX. That is what our theorem was. Okay, read through it. उसने पूरा दिया होगा proof. You will understand it more. Okay, very important, the theorem for use as well as for proof. So you'll note that down in your copies. Now coming to that, we have a short exercise there. 10.1. How many tangents can a circle have? Circle में कितने points होते हैं? Infinite. They are indefinite points on the boundary of the circle, and हर point पे एक एक tangent बन सकती है. So we would say we can have, a circle can have infinite number of tangents. Okay. Then next, a tangent to a circle intersects it at one point. Alright. And then a line intersecting a circle at 2 points is called a secant. आप जब आगे का सब एक बार अच्छे से पढ़ोगे तो ये आपको all clear होता जाएगा. Okay. A circle can have 2 parallel tangents. Okay, so there are only 2 parallel tangents at a time that we can draw to a circle. Okay, not more than 2. कैसे? If you want to understand, we have this figure here. ठीक है, एक ये है tangent, so दूसरी इसकी just opposite यहाँ से, lying on the diameter through this. ओके, ये भी पॉइंट ऑफ कांटेक्ट है. इसको आप एक्सटेंड करोगे तो जो नेक्स्ट ये जहाँ पे मीट करेगा वहां पे जो टेंजेंट बनेगी दैट विल बी पैरेलल टू दिस. उसके अलावा कोई भी आप कहो वो इंक्लाइंड लाइन हो जाएगी एंड इट वोंट बी पैरेलल. ओके, सो वी कैन ओनली ड्रॉ 2 पैरेलल टेंजेंट्स एट अ टाइम. नाउ द कॉमन पॉइंट ऑफ अ टेंजेंट टू अ सर्कल इज कॉल्ड द पॉइंट ऑफ कॉन्टैक्ट. अभी बताया था. देन ओके, नाउ अ टेंजेंट PQ at a point P of a circle of radius 5 meets line through the center O at point Q such that OQ is 12 centimeters. You have to find length of PQ. So figure बनाओगे इसके लिए. This is how the figure will come out to be. Okay. Here. So they had said there is a circle and P is the point of contact. A tangent through P, PQ is a tangent through P, which is meeting a line through O at a point Q, which is at a distance of 12 centimeters. तो ऐसा फिगर बना आपका. ये सेंटर O से Q पॉइंट 12 सेंटीमीटर्स पे है एंड P के थ्रू एक टेंजेंट बनी है where the radius, so OP becomes the radius, is 5 centimeters. So you need to find the length of this PQ. तो आपको एक ये राइट एंगल ट्राइंगल मिल गया. देखो why? Because अभी हमने थ्योरम पढ़ा था radius is always perpendicular to the tangent. Okay, so you would say OP is perpendicular to PQ because radius is perpendicular to tangent from the theorem. Then this is a right angle triangle. We can apply Pythagoras theorem. So ये hypotenuse हो गया हमारा. OQ square is equal to OP square plus QPQ square. So 12 square is equal to 5 square plus X square PQ. So 12 square is 144. 25 इधर आएगा तो माइनस हो जाएगा. So PQ square is 119. हमें PQ निकालना था. अंडर रूट लोगे दोनों साइड टेकिंग रूट. Your PQ is 119 centimeter. I think it was a multiple choice, so D is your right option. Okay. Then next they are saying draw a circle and two lines parallel to a given line such that one is tangent and the other is secant. तो आप और figures बना सकते हो. मैंने एक बनाया है. This was a circle. I have considered this line. आप कहीं और भी ले सकते हो. उसके parallel एक tangent बना दो, एक secant बना दो. Secant is a line cutting at 2 points and tangent touches. मैंने यहाँ पे दो बनाई है to show you the fact that we just studied कि we can have only two parallel tangents at a time. So these are those two parallel tangents that we can draw. Okay, so somewhat like this. You need not draw the other tangent. मैंने आपका वो fact clear करने के लिए यहाँ पे बना दिया है. Okay, so likewise you can draw, children.